hope all of you are fine. Today our topic is about the ECG or EKG, how our heart beats, what is polarization and depolarization. Before that, I want to discuss some interesting facts about the heart beating. There are two main purposes of our heart. One it beats and other one it is pumping blood. Our heart pumps blood round about 2000 gallons each day, 75 gallons each hour, and round about 1 gallon each minute. If your heart stops pumping blood to your brain only for 5 seconds, you lose consciousness. And if your heart stops pumping blood to your brain for 4 minutes, a permanent brain hemorrhage occurs. Similarly, your heart beat for 72 minutes, 72 times in each minute, and around about 1,15,000 times each day. Now, the heart is like a big muscle. So how it pumping blood? This is the main question. So now comes to our topic. Our topic is ECG or EKG. ECG is basically electrocardiogram, and we call it ECG in Pakistan, in UK, and some other countries. It is also called EKG in Germany, in US, and some other countries because there are different concepts about this scale. Some people say that it is invented by the German, that's why it is called EKG, and other people say that it is a Greek word. So there are different concepts about this. The main purpose of ECG is to investigate the heart condition, to diagnose and whether our heart is a defect heart or whether it is a normal heart. So its main purpose is to investigate the heart. Now, how our heart beats? The basic phenomena behind the heart beating is the heart cells. Our heart cells like a chemical battery. Each heart cell generates potential at the order of millivolt. Now, how they generate that potential? For that, pacemaker cells are responsible. These pacemaker cells, which are sinoatrial nodes and atrioventricular nodes, generate electric potential at the order of millivolt. But these pacemaker cells generate how this potential? For that, we have to understand what is polarization, depolarization, and repolarization of the cell. The heartbeat initiated by the pacemaker cells. Now, how it initiated by the pacemaker cells? For that, here we discuss polarized state or resting state, depolarized state, and repolarized state. The heart cell is like a chemical battery. In resting state or in polarized state, inside the potential is negative with respect to outside. Outside potential is positive because there are a lot of concentration of sodium and calcium ions outside the cell. And this state, when the potential outside the cell is positive with respect to the inside of the cell, this is called the polarized state, and the electric field is from positive to negative inside towards inside of the cell. Now, when these positive ions crosses this membrane through gated ion channel, after some time this potential inside the cell becomes positive, and outside the cell the potential becomes negative. When this stage reach, it is called depolarized state. And in depolarization state, the contraction of heart occur, but first atrium region contract and after that ventricle region contract. The heart as a whole cannot contract at the same time. So when the depolarization occurs, the potential inside the cell becomes plus 20 millivolt with respect to the outside the cell. Now, after depolarization, again repolarization occur, and how repolarization occur? When again these ions which are positive, sodium and calcium ion, crosses this membrane through gated ion channel and go outside, then a stage comes that inside the cell again the potential is negative and outside the cell again the potential is positive. This is called repolarization. Repolarization is basically the reverse of depolarization, because in depolarization the cell change state from minus 80 to plus 20 millivolt inside with respect to outside, and in repolarization from plus 20 millivolt to the minus 80 millivolt inside with respect to outside. So, but repolarization occur how? The main reason for the repolarization is that when the depolarization of the cell is sufficient, then due to the higher concentration of the ions inside the cell, these ions moves outside and the cell again repolarize. Now comes towards the sinus rhythm. This sinus rhythm, these wavy lines are generated due to the pacemaker cells which generate the electrical impulses, and these nodes responses to each other, due to which the wave spread down and these electrical impulses are generated. Here you see that P wave is formed. This P wave is basically the contraction of the atrium region, and the atrium region contracted due to the SA node. The sinoatrial node will generate the electrical impulse, and when the heart start beating, the P wave generated, which is basically the depolarization of the atrium region. After the depolarization of the atrium region, when atrium region repolarizes, then the depolarization of the ventricle region occur because the wave spread down. And when ventricle region depolarizes, we obtain this bigger peak, this bigger electrical impulse of the ventricle region. This peak is bigger than this peak. The main reason for this is that the ventricle region contains more muscles. It possesses large area, large region compared to the ventricle region. That's why this peak is bigger than P wave peak. And when ventricle region depolarizes, then after ventricle depolarization, ventricle repolarization occur and we obtain T wave. This T wave is basically the repolarization of ventricle region, which is also called the recovery of heart cell, because heart want to recover itself and again start another beat, because beating are continuous. The atrium repolarization almost take the ventricle depolarization take almost 0.1 second, and repolarization also take 0.1 second. Similarly, the ventricle depolarization takes 0.3 second. So roundabout the whole cycle takes 0.8 second, and we know that in 1 minute there are 60 seconds, and in 1 minute there are almost round about 72 beats per minute. So 60 divided by 72 is equal to 0.8 second. It means that one round cycle or one beat takes almost round about 0.8 second. So this is basically the voltage versus time graph, which is also called the sinus rhythm of heart cell. So I hope you people understand that how ECG of a normal person is plotted. This is the ECG of normal person. If a person is abnormal and if it is a diseased person, then in that case we obtain a wave which is not like this, because this is the wave of normal person. And if this is the wave of abnormal person, then there will be automatically abnormality in P region or R region or T region. The wave cannot be plotted like this. These electrical impulses are disturbed, and that shows us that otherwise either the ventricle region defect is there, or maybe there is a atrium region defect. So doctors then after that suggest that how we can treat that diseased person. So this is the ECG of normal person. I hope you people understand what is depolarization, repolarization, and how our heart beats. So thanks for your time, and inshallah we will appear next time with another interesting video. Allah Hafiz.